Hello, good morning. Switch this up here. Good morning. Good morning, Ashley. How are you this morning? I think I got it. How we doing this morning? There we go. You're working on a research paper. What you researching there, Ashley? I would like to know. What kind of research paper? What research paper are we working on? I hope it's something interesting. I remember doing a research paper about Nostradamus. That was a pretty interesting research paper. Yes. Sociologists Emile Durkheim and Harriet Martineau. Ooh. Now, sociology is rather important. And I won't lie. Well, are they interesting, though? Are they interesting people? I hope so. Here it is, but not me. Okay, that's fair. You like it works on two fronts? One is, one isn't. Okay, that's fair. It's getting set up here for today. It's difficult to write about things that are boring. It is. I don't disagree. I know you could do it, though. My paper on Nostradamus that I mentioned earlier had stuff about monster trucks and mythical fairies. So, yeah, I got a B on that paper. I was plenty happy about that research. You just gotta add a little bit of this and that just kind of is, um, line fillers, There you go. Oh, I can't believe it's already Wednesday. That was really fast, man. Jeez. Already Wednesday? Man, where's the time? 5 pages of line fillers. I got. Hello, Anna. How are you this morning? How are you doing this morning? I hope you're doing good. Goodness. This day is already going to be pretty good. I can feel it. You doing good? Yeah, I'm doing really good, Anna. It's been a good day already so far. Look, I'm get to teach. Ain't nothing wrong with that. I get to have some. I get to get right back at it. I can't believe it's Wednesday already, right? And I just said that. Be like, hey, I get to teach again. It's another rip-roaring day of stats, but more importantly, I get to spend it with you guys. So I think that's the most important part there. I get to have a little bit of fun in and along the way for the next little bit. You guys hopefully get to enjoy a little bit as well. So that's what I'm here to do. Have fun and goof off for like 1 hour and 15 minutes. Let's see. What is the next test? Let's get it. You check that really quick. I can give you. I can't give you a definitive date there, Anna, but what I can give you is what chapter it is after. Okay. All right, that's fine. All right, so I'm going to have a test after chapter now. Kind of deciding which way I want to do this here. Yeah, I think after chapter 7, I think we'll have our next test. So I think after chapter 7, I may do the next test. I'm kind of debating whether it's chapter 7 or chapter 8 that I should probably do the next test after. Of course, as you know, Anna, I would always give you, and everyone else, a word of warning, of course. 8? Ash is like, I want it after chapter 8. Okay. Yeah, I've been actually, honestly, I've been debating whether it's chapter 7 or chapter 8. So maybe it will be after chapter 8. So I'll actually decide on that and see where we're at. But if it's after chapter 8, I'll let you know, of course, in advance. If it's after chapter 7, I'll still let you know in advance. All right, so nothing's going to change there in terms of how I'm going to be approaching things. I'll always let you know in advance and always a week ahead of time at minimum. So I will not lie on this fact. It will be consistent like it always is. I promise you. Ooh, getting some groove today. Good vibes. Good vibes. I know you guys are having hopefully a little bit of fun today. Banner, if we say after 8, will there be more questions than if we say chapter 7? I mean, okay, let me put it this way, Fainer. If you have fewer questions after chapter 7, which is true, you'll have more questions on the next test anyway after that. So it balances out either way. So no matter what, the answer is less now, more later. More now, less later. So either way, it's the same. It's exactly the same, Fainer. I ain't gonna lie. No difference between the two. I'll just be perfectly upfront and honest with you. More now, less later. I like that. I mean, I mean, yeah, that's pretty much what it is. Yeah. Yep. Okay. Strange thing. Oh, I did do that. Okay. Okay. I did it. Less stress closer to the end of the semester. Okay, that's fair. That's fair. Yeah, I take. You know, it's not a bad idea actually. Less stress closer to the end of the semester. That makes sense. It has a lot of validity to it. That has a lot of validity to it, actually. That may actually sway. That reasoning. That's pretty rational. I actually sway my thinking about that. So, very well said. Oh yes, I did promise marbles last time. You're not wrong about this. You are not wrong about this. You are correct. I did promise marbles on stream. Thanks for reminding me, Feiner. Yeah. Switch this. Get this. Do this. Get this. Actually, I'll get this. There we go. All right, as promised, we'll run one thing here. So all right, there we go. Perfect. All right, let's do a little bit of racing. Yes, sir. Yes, sir. Let's do a random map. I don't even know. We'll race with just whoever's in the chat. We'll just race whoever's in the chat there. But exclamation mark and play. So exclamation mark and play, and you can join. There's your marble. Woo! All right. There we go. Exclamation mark and play. You could get involved. All right, let's do this, ladies and gentlemen. Let's play some marbles. All right, here we go. All right, Anna right now is slightly in the lead, but it depends who goes down the funnel first. So we'll see. Oh man, this one's gonna. I think this one's gonna be close. Just feels like it's. This one feels like it's gonna be close. Anna in the lead. Ooh. Maybe Anna's gonna say, "Oh, I don't want this." So this. Anna in a super commanding lead. Holy smokes. Well, I'm starting to catch up a little bit. Anna survived the next funnel. Ooh, Anna gets in there. Look at that. Me in second, Ashley third, Feiner in fourth. Anna with a very commanding lead already. She has to survive, though. That's the important part there. Alright, I'm starting to catch up a slight bit, but Anna's still way out in front. Oh, here we go, here we go. Maybe some momentum will help me. Next funnel down. Oh, here we go. Oh, Anna passes right through. No problems. No problems at all. All right. Anna heading to the finish line. It looks like a clean sweep. Anna headed to the finish. And your winner from wire to wire is Anna. Anna wins wire to wire. Look at that. Oh, I'm stuck all the way back there. Oh, no. Oh, boy. Coming in second is going to be Ashley. And in third will be Feiner. And I come in last. Oh, I'm the big loser. Hey, congratulations, Anna. There you go. You won. Nicely done, everybody. Nicely done. That was pretty fun. GG's indeed. There you go, ladies and gentlemen. There's our marble race of the day. Very nicely done, guys. Very nicely done. We worked really hard on that one. Okay, really, really hard. I ain't gonna lie. You have done very, very well for yourself. How wonderful. Indeed. That is indeed wonderful. All right. Absolutely. 100%, Anna. We all were like, big brains, big brain. The laws of RNG have blessed you today, Anna. Big brain getting RNG in your favor. Alrighty. Oh man, look at that already. There we go, there we go. Alright, we'll wait for, well, it's now 11 o'clock. Okay, we'll get going here. Hopefully we'll have a few more people pop in soon, okay? Hopefully they'll pop in and say hello. Alright. But, oh, looks like we do. Kristen, good morning. Good morning to you. I hope you are doing very well this morning. There we go. Oh, Ziggy says good morning. Good morning to you, Ziggy. Hopefully you're doing well. Cheska, good morning to you. Good morning. I hope things are doing really well this morning for you. Hope they are doing great. All right. Hopefully they're doing really good. All right. Okay, ladies and gentlemen. Ladies and gentlemen, we're going to do, actually, let me skip over the intro here. I need to change cameras. All right, there we go. I changed over to my big face. All right. All right, let's go ahead and do the intro here. Let's get going here with some new stuff here for the end of the week. Let's do it. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we're gonna finish up a little bit about what we did not talk about here last time. Last time we didn't get a good chance here to talk about the end of section 6.2 here. Ashley, I once again have my jasmine green tea with me. I have my jasmine green tea with me of what I had last time. However, if you would like to request, I do have something different in my fridge. So, would you like me to get something different from my fridge since you asked? I do have different things in my fridge, just something slightly different. Okay, give me just a second here. I will go get it. I have returned. All right, so today I have because Ashley asked, I have a veggie veggie shot, veggie juice blend with beta carotene. So this is what I got here today. Hey Wade, how you doing? Megan, good morning to you. I have a veggie shot peach juice blend with beta carotene. It's a big old vegetable fruit juice here. That's it in English. There it is in Japanese. Yeah. All right. Okay. So, hey, if you guys got suggestions, or you guys can send me drinks that are non-perishable or whatever, then I can pick in my fridge. I'll happily drink it on stream, so long as it's not alcoholic. So that's good. You got minutes? Well, yes, I did, but I can if there are other drinks that I should try, more than happy to do that. All right. Okay. All right. So we got the veggie drink here today. All right. So let's talk about what we did from last time, ladies and gentlemen. Um, you tried taking Japanese. I gave up. It was way too hard. It takes a little bit of getting used to. I'm not good at speaking Japanese, but it's not the worst thing in the whole wide world. Writing it is really tough. Kanji is very hard, but speaking it is not the worst thing. So definitely not terrible. Um, all right. So let's discuss what we talked about here. What homework should we be up to? Section 6.2. Section 6.2 is what you should be up to at this moment until after today. Okay, Kristen? That's where we should be after. All right. So from section 6.2 last time, actually, from section 6.2, actually last time we talked about the normal distribution there, or not normal distribution. Talked about binomial distribution. Pardon me. We talked about how to solve things using the wording in the binomial distribution. All right. Now, one of the things that I didn't talk about here last time is because we spent so much time talking about the wording there, I neglected to talk about one other thing here. So I'm going to bring it up here on the screen here. All right. So I asked here, how do we find the mean, variance, and standard deviation of binomial random variable? All right, so we didn't talk about the mean or standard deviation here last time for a binomial distribution. The reason why is because the mean and standard deviation for a binomial distribution here last time, this was question 2 here from the last handout, are very straightforward of which to find. Now, I'll use the same example here that we discussed here last time. In that example, what we talked about, which was the toilet flushing problem thingy, right? That problem last time discussed, okay, we had 64% here. We had 64%, so our probability of success here was 0.64. And the number of people, n here, was equal to 20. We tested 20 people. Yes, ladies and gentlemen, learning Japanese can be pretty tough at times. Writing it is pretty hard. That's why there's 4 tiers to knowing Japanese. There's 4 tiers in Japan. The JLPT test levels. So, however, hiragana and katakana are not that hard to write. It's always the kanji that's the hardest to write. So, okay. All right, so if we talk about the mean here specifically, let's see if we find the mean here from our last example, what we did here last time. So the mean here is going to be, again, taking our n, which is 20, and multiplying it by 0.64. We go ahead and do that here. We could just quickly do that on the calculator. And let's quickly do this on my calculator. So here we get 12.8. So 12.8 reflects the mean here. You don't have to do anything more outside of that. The standard deviation. Now for the standard deviation here and the variance, remember, all you have to do is you can find the variance first. So the variance here is pretty simple. The variance here is equal to np times 1 minus p. As we know, we just have to take the all we have to do is take the square root of that to get the standard deviation. So if we do that here, we take 20 times 0.64 and then times 1 minus 0.64. We just put that in a calculator here, get some random decimal, but don't care what it is as long as it's something. So here we get 4.608 for the variance. And then if we want to do the standard deviation, this is kind of like something that we discussed here previously. We just take the square root of that, and then we go ahead and find out what that is. So let's quickly do that here really quick. And here we get 2.1466. All right. And this is all we get here for the mean, variance, and standard deviation. So if they ask you for those, you'll know exactly how to get those just like that. All right. So that pretty much is the kind of like the last part of section 6.2 that I wanted to talk about, just because we spent the entire time talking about the wording behind the binomial stuff, because that's really the big important parts there. But that's kind of the smaller questions here about like mean and standard deviation and variance. Okay, those aren't too hard to find. They're pretty fast and easy. Any questions about that? I wanted to go over that really quick, and we'll just go ahead and move on. Any questions? Is this like a class? Yeah, it is. You're free to join, though. If you'd like to learn something in and along the way, you're more than welcome to be, you're more than welcome to stick around. Absolutely. If you'd like to learn something, not a problem. Anyone and everyone's welcome. All right, cool. Very nice. Okay. Thank you for the follow, Lecturer Luke. Can we go through a problem like on Monday again? What kind of problem would you like to try there, Megan? So, are you talking like more than, less than, in between? There are several types. So if we go through that problem again, we say, okay. So I'll quickly do this really quick. So we have the probability of success here. Let's take our last example there. We had 64% chance of success there. So again, let's say I wanted to say that, again, let's say n is equal to 20. It says college stats. Now, let's understand what this means. Let's say I have the probability of more than 17. If I took the probability of more than 17, okay, then the one thing to understand here is, thank you, Nikkei. Appreciate you. Thank you for the follow. If we take the probability of more than 17, then what we want here, greetings. Never been to Montreal, so love to go though. I have a friend who's from Montreal though. So the probability of more than 17. Now, what you have to understand here, Megan, is that we want to draw a picture. Okay, we want to draw a picture. All right. So the picture that we want to draw is, what do we want at the end of the day? Okay, I want more than 17. So what I want, so one thing is that if you draw this picture here, Megan, this makes it easy. What we want is something between 18 and 20. I want cases 18, 19, and 20. That's what I'm after here in a problem like this. But I can't just count 18, 19, and 20. That would take me way too long. All right. What I really want to do is, in order to get just 18, 19, and 20, is I'm going to take all the cases 0 to 20. I'm going to take, first of all, I need to eliminate the first 17 cases. So I don't want anything between 0 and 17. And that way, what's left over here is between 18 and 20. Now, how do I do that? Well, all the cases here between 0 and 20, we know that the probability has to be 1. So what I'm going to do here is I'm going to take 1, and I'll subtract it by the probability of 17 or less. Now, to get probability of 17 or less, I'm going to do the binomial CDF. I'm going to do 20, comma 0.64, comma 17. Remember from last time here, Megan, that binomial CDF reflects less than or equal to that number of successes. So understand what's going on here, all right? Not 1 here represents the cases from 0 to 20. You're subtracting off binomial CDF, which reflects all the cases from 0 to 17. And at the end of the day, this will leave you with cases here between 18 to 20, which is essentially what you're looking for here when you say more than 17. And so if you go ahead and do that here, such as in this case, let me quickly do that on the calculator. Got to do it the manual way because my calculator is super old. All right, so on your calculator here, you're going to get 0.0096. Yeah. And so that's what we get here in this particular case for this problem. All right. Again, note the difference here about, again, binomial CDF here is very restrictive to less than or equal to. Okay. So note that that's a restriction on the calculator that you have to work with. You're not given any much of a choice outside of that. Any questions about that? I do have to move forward here, but I just want you to understand if it's a little confusing, draw a picture like this, you know, like kind of like this here. That way you know what you're putting into every spot so you can get the numbers that you're looking for here at the end of the day for those cases that you want. Okay, good. I want to be sure that at least from a picture perspective that it makes a lot of sense when you look at it from like the picture perspective. All right. Good. All right. I'm going to go ahead and move on here. I'm going to go over to section 7.1 here. Brilliance. All right. Let's take a good look here at the next part here, which is sections 7.1, 7.2, 7.3. Now, I'm gonna preface something here really quickly, and that is to say, I know it says section 7.1, 7.2, 7.3. On your homework there, you're only going to have sections 7.1 and 7.2. 7.3 is something that I don't feel is super important, so we're just going to forego section 7.3. And so I may just end up just giving you like, I'll be like, hey, here's 5 free points. Yeah. All right, so I'll probably just end up doing that and just saying, here you go. 5 free points, no problem. This is a bit advanced for you, but I understand this. Trust me, this will make a little bit more sense once we do some new stuff here. This is how probability is done in some shapes or forms. Not every probability is done this way, but okay. Now, let's take a look here at question number 1. What is a probability density curve? So a probability density curve is a curve that represents probabilities of all possible continuous random variables. So one of the things that we talked about here is continuous random variable means that all that really means is that a variable can take on any value. There's an infinite amount of values that that random variable can take. Now that seems pretty complicated, but really it's like saying, again, our volume of water that leaks out of a faucet, that can literally take any value possible, whether that be decimals or whole numbers, okay? They're not a finite amount, there's an infinite amount of volume that you can potentially take or potentially represent. This represents the probabilities in that case. Remember, for continuous random variables, you can basically draw it out to like with as a curve. So it'll look something akin to it could look like this for all we know. This is what the curve could look like. for all we know. But that's what a curve can look like here underneath a continuous random variable. Sure, why not? Uh, I don't know. I mean, I don't really put it into an age group here. I think that so. Hmm, how would I describe this? I don't think it's fair that I put any material to be in a particular age group. You know why? Because I think it's just dependent from person to person on how much they can understand and how much they can grasp. Everybody has a different way of learning. So if I were to say this is made for 18-year-olds, that's not really fair for me to say because, some people have look, I've met a kid who was 13 who could do who could do college level math. So it's not fair for me to put an age restriction or age gap about what you can do and where. That's not a fair assessment. Yeah. I think everybody comes to the table with their own sets of skills and own sets of understanding. So for me to age restrict or discriminate based on that would be, or at least tell you that this material discriminates based on your age would not be a fair assessment. Yeah, frankly, in this stream here, okay? Yeah, there's going to be people. Look, I know that for a fact. Wade, I know that for a fact. There are people who are better than me at math. Okay, that's just a fact. There's always going to be that fact. Okay? Oh, that's fine. That's fine. There's always going to be somebody better at me than at math than me. 100%. Okay? I'm not the greatest thing since sliced bread, all right? I know that for a fact. All right? But I will do my best in order to facilitate the information to have you understand it. And then if you pass that down, to future generations, whatever, then great. All right, fine. Then, or if you use it in your own daily life, then great. That's fine too. It's not. You know, um, I'm gonna do my best for you, because I want to see you do your best. That's all. That's all I really want at the end of the day. Inverse trig and complex numbers. Oh yeah, give that to me. Look, Wade, let's be honest here. I was trash at math too, okay? Okay? Don't forget, I was trash at math in junior high. All right, I had no idea what I was doing in junior high when it came to mathematics, okay? When you practically fail math every year, okay, it was bad, okay? It didn't come from a background be like, oh, you automatically knew math because of this, that, and the other. Like, no, you can't make that assumption about anybody. All right, I was bad at math for a while until I started to put the pieces together. So it wasn't like, yeah, I magically got it. No, it wasn't a snap of a finger either. It was a slow collective roll. I mean, heck, remember, I'm the same guy who almost failed out of college. So, you know what? That's okay. So even if you struggle at a subject, even if you're not very good at something, you just have to work a little bit. It means you may have to work a little bit harder because of how you learn or how you understand, but eventually you get it. And eventually you get better, you know? And you could turn that kind of thinking around saying, "Hey, I'm really trash at something," into something that is better. That is what that is what I understand because I've been there. I've been there at the very bottom of the pile before. Yeah, look, I'm not joking. I'm not joking. I U of I, right? Freshman year at U of I got my 1.75 GPA, right? I got a D minus in one class. I failed another class. Yeah, I pretty much got my butt handed to me by my mom. Told me you got to go out and do it again. You got to go out and try. I tried the next semester. I got better grades. Um, and then I transferred over to some a place where I could learn a lot better. So it's fine. It just takes time. It's not an overnight thing. So hopefully that can help you guys, because you know, it's not a math is not something that definitely just comes natural to everyone. So definitely not me. And I may teach a subject, but it didn't come natural, not even close. But I worked at it, and hopefully I'm good at explaining it. Hopefully. All right, let's talk about probability density curves here, because we got some stuff to do. All right, number 2. What are some properties of probability density curves? Number 1, these properties here are exactly the same properties that we talked about back in chapter 5. So back in chapter 5, when we first talked about probability, there are two things that have to be true in probability. Number 1, the total area underneath the curve is equal to 1. So when you add up all the probabilities, right, of whatever, that always has to equal 1 or 100%. Okay, so at the end of the day, it has to be 1 or 100%. You add up all the areas together, everything has to equal 1 or 100%. And letter B, the height of the graph must be greater than or equal to 0 for all possible values. This goes back to the fact that the probability of anything underneath the any probability has to be between 0 and 1, including 0 and 1. So it has to be above 0, right? It has to be positive, or it has to be above 0. So it can include 0, that's fine, but it can never be negative, for example. All right, so at the end of the day, that graph has to be above board, has to be, say, it could be 0, but again, it has to, again, be greater than or equal to 0 for every possibility. So that's another thing there that's just as consistent as we talked about back here in chapter 5. Now, what's the important part here about probability density curves? There's a lot of different types of probability density curves. That part is true. But the one that we're going to focus here in chapter 7, all right, is going to be talking about number 3, which is our normal distribution curve. So we talked about this back in chapter 3. All right, so it's been a while since we talked about the normal distribution curve, but this was that bell-shaped curve that we talked about from before. So what is the normal distribution curve? It's a curve that is normal in shape, i.e. the bell-shaped curve. So again, what does this look like here once again? This looked like our good friend, looked like this again, kind of went up like this, and then, kind of went back down like that. All right, and there were some properties associated with this bell-shaped curve that we did talk about here back in chapter 3. And this is where we're actually going to now apply this curve to actually finding probabilities. But let's go over those properties here once again to give you a little bit of a refresher. All right, so letter A, the normal curve is symmetric about its mean. So meaning to say, I can take this curve, I can cut it in half, and I could say the rate straight down the middle here is the mean. And I'd have 50% on the right and 50% on the left. Okay, it's a perfect 50-50, perfectly symmetrical. All right, so very, very predictable in that regard. So that's what we like about the normal distribution curve. It's super predictable and super easy to work with. All right, B, the area underneath the normal curve is 1. So just like we just talked about again, the area underneath this whole curve has to be 100%, or 1. So that part has to be true. It's symmetric. I just kind of restated this just for importance. And then finally, letter D, it follows the 68, 95, 99.7 rule. We talked about this rule, aka the empirical rule. We talked about this rule here back in section 3.2, where we had to say you could go +1 standard deviation. This would be like +1 standard deviation. This would be +2 standard deviations, +3. All right. You can go -1, -2, -3, for example. And we could find out how many percentage of the data items are within 3 standard deviations or whatever the case may be. Okay, we had percentages in each one of these boxes. All right, if you want to go back to section 3.2, take a look at those notes and you can see what we're talking about there. Now, I will point out here what's going to be going on here in this chapter is we're not going to be specifically talking about this rule here, okay, the 68, 95, 99.7 rule. We are going to be finding probabilities, but it may not be as clear cut as saying +1 standard deviation or -1 standard deviation, now we could have different things floating around, different amounts of standard deviations away from the mean. So we're going to find different probabilities associated with that. Alrighty. So that is question number 4. Are there any questions about that so far? Any questions? Ooh. Okay. No, indeed. All right. B30. All right. All right. All right, ladies and gentlemen. Why don't you help me out here? Let me show you how section. Let me show you how this section is going to work out. All right. Let me show you how this section is going to work out. This is section 7.1, ladies and gentlemen. All right. All I want you to do here is to tell me if the following graphs look like a normal distribution or not. So does it look like a bell-shaped curve or not? That's all I care about, okay? What I'd like you to do is to type yes or no in the chat. If it is yes, it's a bell-shaped curve, yes, it's normal, or no, it's not normal. Simple enough. Let's look at number 19, yes or no. Normal or not? Or yes, it's normal, no, it's not normal. Let's look at 19, number 19 here. Yes, yes, and yes. All right. All right, very good. Number 19, yes, this does look pretty close to resembling it, right? This looks pretty close to resembling a bell-shaped curve. So this would be indeed a normal distribution type of curve. All right, doesn't have to be exact, by the way, but if it's close, we'll say yes. How about number 20? Yes or no? It's skewed, that's correct, but a skewed graph is not a normal distribution, right? It is skewed, right, that's correct. All right, the answer is indeed no. All you gotta do, all I want you to do, ladies and gentlemen, is compare, all right? Compare the shape. Compare the shape of this curve, a bell-shaped curve, to what you see on the screen. Let's look at 21. 21? 21, yes or no? Number 21, yes or no? That's this curve right here. Oh, man. No, okay. All right, that's correct. All right, let's look at 22. Yes or no? 22, yes or no? Yeah. Yes. Snow. So. All right. So the answer to 22 is indeed yes. All right. So that isn't too hard, right? Effectively, that is in the entirety of section 7.1. That's all I wanted to talk about. It took me 5 minutes of your time. All right, very good. Yeah, that's it. That's 7.1. Yeah, great. that's that's all of a section. Look at picture. Does picture match graph? Yes. Good. We win. It's a yes or no. Oh my gosh. That was so easy. I know. This is what yeah. Some days are like this. I'm just gonna be honest with you. Be like, oh my god. And be like, yep, sounds about right. Yes. Um right. Alright, let's move forward. Let's move forward, ladies and gentlemen, away from this. Let's do some other problem. We're gonna do section 7 too. You're like, Megan's like, I don't have to worry about anything else. You're like, oh my gosh. I'm like, yeah, that's kind of true. All right, let's move on here. Pretty much, Tristan, for section 7.1, yeah. It's like, oh, here. Oh, where's the which graph has the mean of this? And you're like, okay, look at picture, identify picture, point, point, point. Yeah, yeah, yeah. That's for just that section, though. There's not much in section 7.1, to be honest. Really, it's just a reiteration of what we already talked about before. So, okay, cuckoo. Okay, now let's talk about the next part here, because the next part here will take us the rest of the time here today. So, I don't expect us to get through everything here today. We will work a little bit more on the end of chapter 7 here. So, we'll take our time here with this section, section 7.2, which is the last section of chapter 7, technically. So we'll go slow here and we'll talk about it. All right. So number 5, I'm going to kind of skip around here just a little bit. So I'm just going to point this out here, and I'm going to skip around on purpose here. Just I will talk about this here. So how can we use z-score to find the area underneath the curve? Okay. Now we talked about z-score way back in chapter 3, but we didn't do much with it. All right. But to give you a reminder here, there is a few more questions here. So I put questions 7, 8, and 9 here are related to z-score. So let's talk about what z-score is specifically, at least in terms of its formulas, to give you a nice little refresher, and then we'll go back to question 5 in just a moment. So how do we find a z-score with mean and standard deviation? Well, z-score here is equal to the data item minus the mean, so you subtract those two together, divided by the standard deviation. All right. So we did talk about that before. We said, okay, you plug and chug in the values. You remember you're given a mean and standard deviation as part of a data set if you already have computed those out. And if you want to find this respective z-score here, that's fine. Now, what does a z-score represent? What does that mean, right? So I put here for number 8. What are some properties here of z-scores? Remember that a z-score here represents how many standard deviations a data item is away from the mean. One of the properties that we talked about z-scores here previously is that z-scores can be negative, okay? So meaning to say they're to the left of the mean here on the chart. So again, go back to our little picture here for a moment. A z-score that would be negative would be over here. Okay, so this would be a negative z-score here. All right. And over here would be, let's say, like, for example, a positive z-score. So you could work both ways, okay? Again, we just don't know which way, but again, that's generally how it works, okay? It's really not too hard, all right? Remember that each z-score here is unique to its respective data item. So no matter what the data item is, okay, every data item has a unique z-score. So if it's the same data item, they're going to have the same z-score. But if it's a unique data item, it'll have a unique z-score associated with that based on the formula that we are given here to find that particular guy. And probably the most important thing that is going to be relevant for what we are going to be doing here in this section is each z-score can be linked to a percentile. Meaning to say, we can now effectively, because we could find a z-score and link it to a percentile, now that could be like at the back of the book or whatever, but with it linked to a percentile here, this means that we can now bring probabilities into play when it comes to certain scenarios that we can, when we assume that it's going to be normally distributed. Okay, so those are some properties, those are some very important properties there of z-scores that we do want to kind of point out. If you want to find, for example, here, this number 9 here, how can we find a data point associated with the z-score? Well, you can actually find the data item here. The data item here would be equal to the z-score times the standard deviation plus the mean. If you want to find that specific data item that goes with that z-score there. All right, we'll look at that one right now. All right. Now, I know I kind of sidebarred here with these 3 questions here with questions 7, 8, and 9, but it is important for us to point out that that these z-scores here will play an important role here for several problems here that we're going to be doing here today. So um, we won't be focusing entirely on them, but still, at least for the basic idea for what we're going to be doing, it's going to mean something. Okay. Any questions about that so far? No. All right. Let's see. Okay, that worked. That worked. All right. Okay. All right. So let's take a good look here at number 5 again. All right. Now that we have a now that we have background about what a z-score is once again, let's talk about how we can use it to help find ourselves some probabilities. So how can we use a z-score here to find the area underneath the curve? Okay, now what we're going to be using here is we're going to be using 2 functions on the calculator. All right. So we are going to be making the assumption here in these examples in section 7.2 that we are underneath a normal distribution. Now, the 2 functions on the calculator here that we're going to specifically find, in order to find those 2 functions here, I would like you to first, if you have a calculator, please make sure you take that out. And we're going to go ahead and hit the second key and hit the vars key. Okay, hit the second key and the vars key here. And we're going to get to our distribution menu. This is the same menu that we used back in chapter 6 for the binomial. The only thing is that we are going to be using 2 functions on for this particular section. We're going to use 2 functions here, and that is options 2 and option 3. We're going to use normal CDF, and we're going to use inverse norm. All right, we'll talk about both. We'll talk about inverse norm here in the next question, but first let's focus on normal CDF. Now, write this down in your notes to be extra sure that you don't do something wrong here. So I do put this down here as a note. Normal PDF will never be used. So this first option here that says normal PDF, this will never be used for our course. All right? Ever. All right? So be sure. I know last time in chapter 6 we used binomial PDF and binomial CDF. Yes, that's true. But we are not using normal PDF in this course. Okay. So you can strike that from the record, strike that from your brain. You should never use number 1. The only 2 functions we want to use here for normal distributions are numbers 2 and numbers 3. That's it. Okay, these are the only 2 we want to use for this section here. All right. I put that note down on purpose because of the fact that, yeah, we're gonna have to make sure we're using the right function. All right. Okay, so how does the formatting go for normal CDF? let's talk about that here. Okay, so I'm going to go ahead and click on Normalcdf here on the calculator, and then we'll discuss the formatting here together. Okay, so for Normalcdf here, we have 4 values that we have to put in. Okay, so if you have the old school calculator here, definitely make sure you write this down so you have at least the formatting there of which to help you. Oh, let me move that up here. Sorry about that. There we go. It's a bit better. Okay, so Normalcdf is going to work like this. We have a lower value, we have an upper value, we have the mean, and then that follows by the standard deviation. That's what each one of these values here represent, okay, in that order, right? For lower value, upper value, a mean, and standard deviation. Now, one thing to keep note about here is that we are going to be using 0 and 1 here. 0 is the default mean, and 1 is the default standard deviation. Now, this is if you are not given any information regarding your mean and standard deviation. So if you don't have a mean and you don't have a standard deviation, so let's say you're not given any of that information whatsoever, then you could put 0 for your mean and you could put 1 for your standard deviation as a default value. Okay, so we're just going to make, at least to start with, we'll make that assumption here in this instance. Okay, if it does give you a mean and standard deviation in the problem, which we will look at as well, then we put those in appropriately. All right. Now, let's take a good look here at the problem here, and we'll work through it. We'll work through it together here, and we'll see exactly how it works. So, break out the book here for just a moment. Okay. So what I'm going to do here in this case is I'm going to do an example here. We'll just do number 5. It says determine the area underneath a standard normal curve that lies to the left of, and we'll do yeah, we'll do this first one here. Let's do negative 0.43. Why not? We'll do negative 0.43. We'll see exactly what we're working with. All right, so let's write that down. Let's write that down in this case. So what we want here is we want the area to the left of the z-score here of negative 0.43. Okay? So the key word here is, of course, to the left, right? So that's the key word here, is to the left. Everything to the left. So how does that look like here? Everything in a box to the left. I have to say that every time. I don't know why. That song is too good. Anyway, let's say negative 0.43 is right here. This is where, say, z is equal to negative 0.43. All we want to do is find this area right here. Everything to the left of that thing. Yeah, this is all this gobbledygook in black. Okay, this is what we want to find here in this instance. All right, so the question is, how do we go ahead and do that? How do we find this area to the left of z is equal to negative 0.43? Well, that's where this is going to come in. Let's go ahead and go back to our notes here for just a moment. If you see this wording here, we see below, less, or left, using z-scores here. I'm going to go ahead and put this down here as our guy. It says Normalcdf, negative 1e to the 99, the upper value, which we'll plug in, 0, comma 1. Again, the reason why we're using 0 and 1 here is because in the problem in the book anyway, for this book problem anyway, there is no mean and standard deviation that's given to you here, so we're just going to use the default values in this instance. Now, the the question really becomes is let's follow this together here. Okay, so let's follow this together. So first of all, you see this negative 1e to the 99. What does that even mean, negative 1e to the 99? In effect, negative 1e to the 99 represents negative 1 times 10 to the 99th power. But this is the calculator's way of saying negative infinity. Okay, the calculator doesn't truly have infinity on it. It only goes up to a certain amount of numbers. But this is basically negative 1e to the 99 is basically the same way of saying negative infinity at the end of the day. Now, how do we enter that into the calculator? That's the more important part here. So in order to enter this into the calculator, we're going to put negative. Don't forget to hit the negative key. Not the minus key, but the negative key. So negative 1. And to get the blocky letter E there on the calculator, so put this in chat here. All right, so you hit the second key and then the comma key to get the blocky E here. So the second key and the comma key to get that blocky letter E there. So the second key and the comma key. And you hit 99 for that. The upper value here is going to be negative 0.43. So that's our upper value here. And we have 0 and we have 1. So what should this look like here? Let's go back. Be Normalcdf. All right, negative 1e to the 99, comma negative 0.43, comma 0, comma 1. If you have the old school calculator, this is exactly what it should look like here as you enter it in. Go ahead and paste this around. All right, and so here we get 0.333 6. All right, fine. All right. Want to be sure that everybody got this right here. Please type in done if you got this right in the calculator. Make sure that everybody's on the same page here. Please type done in the chat if you got this in the calculator exactly correctly. Make sure everybody is on the same page here. Dobo. I don't even know what that means. Down. Feiner says down. Oh. Gotta be careful. I got auto things on, my friend. Sorry, Connor. I got some auto things put on. So F. That was Nightbot. That wasn't me. I don't know what he put, so I'd have to go back and look. I might have to change up my Nightbot a little bit to not do that necessarily. Sorry, Connor. Made up an amazing question. Oh no. You know, you could just put it on the Discord. I mean, I'm just saying. effort though while I'm here. Hey, that's a you problem. That's not a me problem. I can't make you do things, but if you don't want to put effort, well, I'm not gonna make you. All right. All right, good. Tonight, not problem, not gonna lie. All right, fair enough. All right. Okay. All right, very good. So everybody got that. Let's move on to the next one here. I hope you're doing good today, Connor, though. Hopefully today's been good. All right. Let's take a good look here at a next one here. Determine the area underneath the normal standard curve that lies to the right of, in this case here, we'll go ahead and use 1.78. Why not? So, doesn't really matter what we use here. Just, I'm going to make up anything, really. Why don't I make up something? So at the area to the right, area to the right of, let's say the z-score here of 1. Let's go 1.13. Why not? All right. So in this case here, if we take an area to the right, again, the key word here is the area to the right. So in order for us to do that here, let's go back to our notes here for just a moment. If we go above or more or to the right, we do normal CDF, the lower value, 1e to the positive 1e to the 99, and then 0, 1, since in this case we're not given a mean and standard deviation here. All right. So let's, in this case here, we would have normal CDF. All right. We would have 1.13, comma, 1e to the 99, comma, 0, 1. Again, it has to be lower and upper. Make sure you do not confuse the two numbers. Okay, make sure you don't flip them around. Right, so that would not be the wisest thing to do. All right, so let's put this in here. We'll hit second and vars. Go to normal CDF here. We'll put 1.13. We're now going to put in 1e to the 99, so put in 1. And we'll put second and e to the 99. And put 0 and 1. Put paste. And we'll hit enter. All right. And here we get 0.1292 as our answer. All right. All right, good beans. Stuff. All right, no problem so far. Questions about that? Any questions? Any questions? Nope. Okay. Okay, that's perfectly fine. Perfectly fine. All right. Let's move to the next example here because there's a few more that we definitely have to do here. So let's do the next one. All right. Go. All right. So the next problem here is like saying, all right, determine the area underneath the standard normal curve that lies between. All right. So I'll make up a one here that goes between two values here. So the area between, let's go with z is equal to negative 1.74, and z here is equal to 0.13. Okay. So can anybody tell me here, if I'm trying to find the area between, we're going to use normal CDF. That part is true. All right, so there's only two functions we're going to be using here in this section. Normal CDF, definitely one of them. What numbers are we going to put underneath the normal CDF? What are we going to put here in this case? if we want to find the area between two z-scores. What should I put here? What are you going to have? I'm going to enter that in the calculator. What should we do here? What do you think I should have here? What should I put underneath my normal CDF? What numbers am I going to put? Do I subtract the CDFs? No, not at all. In fact, you can actually put these together. Megatoast says minus 1.74, 0.130, and 1. That would be correct, yes. So here's the nicest part about normal CDF, is that with normal CDF specifically, it's with normal CDF, you could actually just go ahead and plop them in together, and you can find anything else in between without any trouble. So, I put 173. It should be 174 here. So negative 1.74, 0.13, and 0 and 1. So that's the key difference here. A binomial CDF had a very restriction to it. As Megan was thinking, oh yeah, that had a strict restriction to it. Does normal CDF have that same strict restriction? And the answer is no, because in this case here, you can find between two z values. That's perfectly fine. It's much more direct for a normal CDF than it is for the binomial. So that's actually going to be very handy for us and very helpful for us to do a lot of these types of problems. Go ahead and hit paste here. Let's see what we get. 0.5108. All right, there we go. So you could just do it all at once, and there you are, an area between two z values. Yes. Any questions about that? Any questions? Ooh. Yeah. I wonder if that's happened. Check that really quick. No? Okay. Check something really quick. And, well, I think they did. Okay. I think they, did they, I was actually following, this morning. Did they pass the bill this morning for the COVID relief checks or stuff like that? I should check that really fast. Kind of like on my radar this morning. Oh, okay. So I guess they are going to. All right. So hopefully today the House of Representatives will pass the COVID-19 relief bill. So hopefully people in the chat will be getting $1,400 for free in the mail or directly deposited into your account. So hopefully that will come today. So it's one of the things I was kind of checking on today. So yeah, because if they pass it today, they're going to send it directly to the president, and the president is expected to sign the bill. So right away. Yeah, so that's happening right now. As if once they pass the vote, then it'll go directly to the president to be signed, and people get their $1,400 and extended unemployment benefits. There you go. That's how it is. What happened to the $2,000 promised? Well, technically you did get the $2,000. So, okay. This is kind of a little difficult. No, this is not so difficult to explain, but you already actually were deposited $600 in January. So you should have gotten $600 in January. Now you get the other $1,400 now with this bill. So you do get the $2,000 that was promised. Right. So it's at first it doesn't sound like you got the actual money that you were promised. In actuality, you will get the money you were promised. It's just done in 2 chunks. All right. Let's look at the next one here. Next example. Next example, ladies and gentlemen. Let's do this. Hey, hey. What happened? Hold up a sec. Something happened. I'm not too thrilled about it. Give me just a second, folks. All right, there we go. All right, that was kind of weird about the stream there. All right, had to do that little tweak there. Okay. There we go. All right, next example here. Let's do it. All righty. So the next example that I want to show off here specifically is going to be this next one here. Says number 13. Find the z-score such that the area underneath the standard normal curve to its left is 0.1. All right. I'm going to find the area, find the z-score that in which the area to the left is 0.1. All right. Let's do that one. So now we're going backwards here. Okay, so understand what's happening here. We are now effectively going backwards because now we're trying to find the z-score associated with an area. All right, so there is a distinct difference between the two concepts. All right. Now, how do we go ahead and do that here in this instance? Well, let's go back to our notes here for just a moment. Okay, so we're going to go back to our notes here for just a moment. And we need to talk about this here in greater detail. That's going to be here what we're going to be doing here for number 6. Number 6, how do we use the area to find a z-score? So we're going to use another calculator function here. This time we're going to use the calculator function that is called inverse norm. Okay, and let me move this over here to the right for a good reason. Let's show that off on the calculator here. We're going to use inverse norm here. Now to find inverse norm, once again, hit the second key and hit the vars key. So if we go to second key and the vars key here, we're going to go down to number 3, which says inverse norm. Okay. I want to point this out on the screen here. All right, let's talk about this. We have the area, we have the mean and standard deviation. Again, if we're not given a mean and standard deviation, use your default values of 0 and 1 respectively. However, I want to talk about that fourth thing that you see there on the screen, which is tail. Now, if you have an old school calculator, you obviously are not going to see any of this. All right. If you have a newer style calculator, you may not even see the tail portion on your calculator. Maybe, maybe not. This last option of tail that you see here on the calculator was more recently added. It was added like maybe a couple years ago or so. Okay, so this was one of the more recent additions. So even if you have a newer calculator from like 5 years ago, it may not be on that software either. Okay, so if you don't see that on that software, then don't be surprised, even if you have a newer style calculator. Newer calculators will definitely have this for sure. Now, what it is specifically, and I do want to state this here, is that if you have an old school calculator or software that doesn't have that fourth option that you see there on screen, all right, then with the tail option, then it will always default to the left, okay? It will never, you can't get center or right here, for example. It'll just default here to the left. So no matter what, for old school calculators, it'll default to the left. So we're going to make adjustments here as necessary if we default to the left automatically. All right, so I just want you to point that out. I want to point that out here. Old school calculator, maybe slightly older software calculator will default to the left because you don't see that tail option necessarily on your calculator. This is new software, the newest, most up-to-date software, so this does have the option here in this instance. Now, in this case here, we're going to go ahead and hit 0.1, since that is going to be the area underneath the curve for this question. We're going to go 0 and 1 here, and we'll go ahead and go down to paste. So this is what it should look like here, inverse norm. Now you don't need, if you have the old school calculator here, by the way, if you have the old school calculator or you don't have that fourth option, then you just need to enter in the three numbers here of 0 and 1 here. Okay, so 0.1, comma 0, comma 1 is what you should have. If you have the newer style calculator, you can plug in left if you want. That's fine. That is not a problem. And so if we do this out here, then here we get the z-score that we want here, which is negative 1.2816. All right. So that's what we get here in this instance. All right. Questions about that? Hey, Aiken, how are you, my friend? Any questions about that, guys? Nope. All right. Now, let's say, for example, here, all right, so I got to do this next example here. Let's say I find the z-score here. Let's say in this case, because we're running out of time here, so let's say we're finding a z-score here with an area to the right. Yes. Yes, I can. So toaster, it's going to be area, mean, and standard deviation. Okay, so area, mean, and standard deviation. So let's say we're finding a z-score here with an area of point, no problem, my friend. Let's say 0.37 to the right. Okay. So if you're trying to find a z-score here with a 0.37 to the right, then you could do it two ways. Let's talk about both ways here. Okay, so what we want to have here is we have inverse norm here. You can plug in 0.37. You can plug in 0 and 1. Now, if you have the option of the tail, you can just go to the right and you'll automatically find that there. Okay? Should be 1. So I can do this really quickly. I can just do this and I could just immediately get my answer here. So I'm going to find my answer right away. All right? But I know not all of you have the option for this part. So don't worry, I'm going to show you the other way of doing this. So the answer is 0.3319. Okay, so we now have an idea. We know what the final answer has to be. But let's see if we can replicate it a different way, because I know some of you have the calculator which defaults automatically to the left. So how does that happen here? Well, drawing a picture is very, very helpful in this circumstance. Okay, so let's talk about that here. If we draw a picture here of what we want, What we want is stuff that is 0.37, like 37% here to the right. That's what we're looking at here. However, since some of you have calculators that are off to the left, what we want to actually find is we want to find this remaining area here. If we say 0.37 to the right is the same as saying 0.63 to the left. Okay, and to get that here, I just did 1 minus 0.37, and so we got 0.63 to the left. So another way to get this answer here, and we're going to do this together here, is we can also put inverse norm, and this is for you guys who have the old school calculator, you guys can put 0.63, comma 0, comma 1. So let's do that and see if we get the same answer. Second in bars, go to inverse norm, put 0.63, 0, 1. This time I'm going to put it to the left. Again, this is for you guys who do not have that tail option. So I'm going to put it to the left because that's what it is on your calculators there. And if you put paste there, and we'll go ahead and take a look. And as you see there, you get the same exact answer that we just got if you didn't have that option. So you can see two different ways to net the same exact answer here at the end of the day. Okay. Are there any questions about that example there? Any questions? We'll talk about, so that's a wonderful question, Dimar. We are going to talk about that question on Monday. So we have the center part there to talk about. So we're going to talk about that because that's a different, that will be a different approach to that question. So I will acknowledge that here. We ran out of time here today, but we're going to talk about that particular example on next Monday. We're also going to talk about problems in section 7.2 that have a standard deviation and mean are given to you here. So we're going to do some examples of that here, but I'm kind of taking a slow approach to this to get you comfortable with that. So yeah, you could do up to section 7.2. There may be some problems you may not know just yet, Megan. So if you're not sure about some of the problems on section 7.2, that's okay. We're going to finish out section 7.2 here on Monday. All right, so we're going to do that next week. All right, so we're just going slow through this section here because there's just kind of a lot in it. And so, but I want you to get at least a little comfortable here. A lot of calculator stuff kind of floating around, so no problem. Okay. So, any other questions here? Any other questions? We're going to cover Dimar's question here for Monday, which is doing the center example. That will also tie into one of the other examples I have planned. So that is for Monday. So we have still going to do a lot of stuff here for sure. Yes. Wade says, by the way, yes. How can I help? Are the numbers we get for the area, are they represented as percentages? Yes. That is correct. Yes, that is correct, Cheska. Are the numbers we get for the area, they represented as percentages? Yes. Yes, they are. So 0.37 would represent 37%. That's correct. Right. 63 would represent, say, 63%. That's right. Yep. Chibsy, the main character that had to train to get his skills like math in a world of broken side characters. Thanks for saying this stuff. Thanks for saying this stuff here that you change yourself means. Yeah. No, thank you, Wade. Yeah. Yes, Santa. Absolutely, 100%. Remember, change doesn't always come in a day. It's sometimes a slow process. But if you find yourself in a better place than you were before, then that's exactly what we're all after. Positive progress, ladies and gentlemen. Positive progress. We're all after positive progress. Let's make it happen. I like positive progress. My favorite thing to do. We do our best. All right, ladies and gentlemen. I want to thank you all coming out here to the stream once again. All right. I have another class here in 10 minutes, of course, so I'm going to be still staying on here. No problem. But for those of you from the first class, I want to tell you thank you so much for coming on out here once again. Have a wonderful weekend. All right. Everybody, take care of yourselves. All right. We're going to continue on with Section 7.2 for next time. All right. And as always, everyone, ladies and gentlemen, as always, stay healthy, stay safe, and most importantly, everybody, stay sane. Have yourself a wonderful weekend, everybody, and we will see you later. All right, take care, everybody. Have a great one. Bye! Alright, I'm back. I am back. Alright. Yes, sirree. Alright. Just waiting for the second class to arrive. In good shape here. Oh, why? Why have I done things? Alright. Let's undo. There we go. I undid it. Oh my goodness. Buenos tardes, indeed. Hello, hello, hello. How we doing? How are we doing? I hope you're doing good. Are you doing good here today, Athena? Great weather, windows open. I gotta go outside. I haven't been outside today. Oh, it's good weather. Is it 60s today? Let me check the weather. I haven't even seen the weather here. Let's see, what is the weather? 62, wow. Oh, next Monday. That's a bummer, next Monday. Alright, it was only one day, though. Alright. Yeah, I'll take that any day. Holy smokes. Sure. Just walk the doggos? Excellent. Excelente. That sounds pretty good to me. Your dogs are adorable. I ain't gonna lie. I ain't gonna lie, your doggos are amazing. I gotta check if they actually did do that. Hello, JD. They are your pride and joy, yes. Doggos. Doggos are amazing. Love dogs. JD, hello, how are you doing? I hope you're doing well. I'm currently watching House TV on CNN. Just checking to see if they actually pass the final bill. So if they pass this bill, then it's then finally it all passes, and then we all get our $1,400. Okay. So this should probably pass. I wouldn't doubt that it wouldn't pass. Yeah. Yeah. It's like, I want more money. Be like, yeah, I do too. Okay, okay. Hang on a second, ladies and gentlemen. Hang on. Alright. Let me bring it up again. Go back. This is happening right now. Alright. Let's go to the house floor, ladies and gentlemen. Time to turn this off for a second. Alright. So this is the, I'm going to switch to my main screen here. All right, so this is what's currently on my computadora. So this is what's going on right now. If this motion passes, right, then the $1.9 trillion package will be passed, and you'll get your $1,400, through the mail, or you'll get your $1,400 through your bank or whatever electronically. So this is finally that thing that has been talked about for like months has finally come down to this vote right here, right now. This passes in the House, then they will give it over to President Biden, and then President Biden will sign it right away. And then basically we will have new laws in effect and new money put into the system for COVID-19 relief bill. So yes, this is happening right now, and everybody's like, yay! This should pass. If this passes, then everybody is like, yay, for a while. So they're like, finally, The Rock has come back to Brooklyn or something like that. So yeah, so this the voting process here does take a while. I'll be honest with you. This is going to take like another like 20-30 minutes or so. Although it has time remaining, but people vote really slow with the pandemic and stuff, so it's going to be pretty common that happens. But once this passes, then okay, we'll be in great shape. Well, hopefully we'll be in better shape. All right. All right, ladies and gentlemen, though, as compelling as it is to watch your votes go up, we got work we got to do here. Do some work. Much as I want to continue showing that off, let's do work. Work is important. All right. Yeah. No, wait. Okay, I need to do that. All right. All right, let's do some intros and let's get going here, ladies and gentlemen. Let's do it. All right. Okay, let's get started today. Welcome back. Welcome back to Wednesday, end of the week time today. So for today we are going to finish off one of the sections that we talked about last time. We finished off section 6.2. I didn't do all of section 6.2 because we wanted to focus primarily on the wording there for the binomial distribution. That's one of the things that we had talked about last time here. But I did not do one other question from that handout last time because this next question here really didn't do a whole lot in terms of it's a pretty quick question here, but we're going to go over it anyway. This is in reference to a binomial distribution. So this is from the last handout here that we had discussed from before. So let me go ahead and put up the big board here, and we are going to talk about it. Yes, let's do it. Okay. So, man, hello. Yeah. All right. So let's look at number two. Number two says, from the last handout, says, how do we find the mean, variance, and standard deviation of a binomial random variable? Okay. So the mean here is the mean and standard deviation. They're really easy because all you have to do is look at n, which is the number of people in the study or whatever, and your sample size, and p, which is the probability of success. So n times p is the mean. It's like standard deviation is n times p times 1 minus p. Take the square root of that. So we could use our previous example from before, our flushing problem with your foot problem thing. And in that particular problem there, we said that 64%, we had 64% of people flushed with their foot. Okay, and so that's going to be 0.64 here. And we took a sample size here of 20 people. Okay, in that example that what we did here last time. Okay, now having said that here, in this instance, right, if we want to find the mean here, all we have to do straight up is just take 20 times 0.64. All right, so 20 times 0.64. And so here, for a mean, we get 12.8. Right, so that's the mean, just straight up. Very simple, very straightforward. Right, requires very little to no effort to actually do. So very, very nice. All right, let's also talk about the standard deviation. So for the standard deviation and variance, for example, you can easily find the variance because the variance is just the standard deviation squared, or you could just take away the square root in this case, and you can find the variance straight up. So you could do np times 1 minus p, and so you could do like 20 times 0.64, and then times 1 minus 0.64, for example. Yeah. Sure. So if we did this out here specifically, what would we get here? We would get here, so this would be equal to, so let's just go ahead and do this out quickly. So 20 times 0.64 times 1 minus 0.64, 1 minus point. Okay, so here we get 4.608. All right, and then the standard deviation would be the square root of 4.608. So we can find the variance right away, and then we can find the standard deviation right away. Really requires little to no effort. And so if we take the square root of that, get 2.1466. Okay, so there we have it. We have our mean and standard deviation. I didn't get a chance to talk about that last time, but now I have a chance to talk about it now. So there we go. That's not too hard. There you go. Simple enough. All right. Okay, so any questions about this question or what we did last time? Any questions about that? Nice. All right. So hopefully that makes it the nay. Nay, indeed. All right. Good beans. All right, good beans, good beans, good beans. All right. So we're gonna move on to the next section. The next section here, or next chapter, I should say. Excuse me. So let's move on to the next chapter, which is sections 7.1 to 7.3. Now, I am going to point a couple of things out here, so let me talk about this here for just a moment. There is a section 7.3 in the book. I'm not going to put any homework associated with section 7.3 on your homework there. So probably what I'll just end up doing is I'll just end up just giving you a free 5 points for that section. It's not even listed, but I'll just end up giving you like 5 points toward your homework score or whatever, and then that'll be fine, something like that. So that's pretty much how that'll go. All right. So yeah, um, that's fine. And so it'll be just the homework there will only cover sections 7.1 and 7.2. So there'll only be 2 sections here in chapter 7 that will primarily cover. So we will cover 1 question from 7.3, but it's really not a huge question anyway. So I'm just letting you know in advance about that there. Let let me get. Actually, I asked the last class this question here, but let me get your opinion on this as well. Uh, I'm trying to make a decision here. I'm trying to see if I'm gonna put a 1-minute poll here. I want to see if you guys would prefer to have a test after chapter 7 or after chapter 8. I gotta give one, but I'm gonna give a test after chapter 7 or a test after chapter 8. I would like to know your opinion about it. I'm making a due consideration in regards to that. So, um, so the way it will work here is that if it's after chapter 7, you'll have less questions, but you'll have more questions on the next test then. Otherwise, it'll be after chapter 8, and then you'll have more questions on this next test, but then less questions on the last test before the final. So that's pretty much how I'm kind of thinking about it. As one person remarked, it's like, oh, it's give you a little bit of peace of mind toward the end of the semester. All right, so many of you said chapter 7. Okay, that's something I'll have to take into consideration here. I'll make a final decision once we get to the end of chapter 7 here. I know there are only 2 sections here, but we're not going to get through chapter 7 here today, so that's for sure. But I just wanted your opinion about that, so that way it'll give me something to think about here over the weekend about what I would like to do. All right. Thank you for your feedback. That's well appreciated. All right. So let's go ahead and talk about section 7.1. All right, which is talking about, basically in section 7.1, we're reiterating a lot of things that we had already discussed about. But let's talk about it here. What was the average score from the last test? I don't remember exactly. I'll have to look that up again. I forgot. I'll let you know. I'll let you know if you ask on Monday, JD. If you ask again, I will let you know. FIFA King, how you doing, my friend? I hope you're doing good. All right. So let's take a look at question 1 here. So question 1 says, what is a probability density curve? Okay, so a probability density curve is a curve that represents probabilities of all possible continuous random variables. All right. I don't even know what the heck that's supposed to mean. That's like dumb. That's a dumb comment. It's just dumb. Um all right. All right. I don't want to have to do this. I really don't want to have to time you out, FIFA King. We'll have to time you out here for doing silly things. So I like you, FIFA King, but you need to take a timeout for. I know I don't like doing it. I don't like timing out people. It's sad. I don't like doing it. It makes me so sad. Oh well. I'll untime. I'll untime him out. And all right. All right. So, probability density curve, a curve that represents probabilities of all possible continuous random variables. All right. So let's talk about this here for just a moment. We're talking about continuous random variables here in this particular section. All right, so what are continue again? Remember, we talked about continuous random variables way back when. That was just like talking about where we said, okay, the amount of volume of a water that flows out of a leaky faucet, that can take on an infinite amount of values. That's again a random variable that can take on an infinite amount of values here in this instance. Now, when you have a curve, essentially it could be any curve because when we talk about continuous random variables, it can take on any value here. Again, it could be any curve here at the end of the day. You can draw out probability curves that are continuous here as a line. So it could look something like, it could look something like this. This could be the probability variable. It's some random curve. It's got stuff associated with it. That's great. All right, so not the greatest thing in the whole wide world, but it's a thing. So there you go. All right. In any case, let's talk about what we're going to be doing here next. Let's jump. Okay. Now, let's talk about the properties here of a probability density curve. So what are some properties here of a probability density curve? All right, so the first one here, these are two properties that we've already talked about and seen before. Okay, so we've already talked about this pretty ad infinitum in some respect. All right, you've seen it in some form or fashion here, but what are those properties here once again? So those properties here is that the total area underneath the curve is equal to 1. So this is the same thing we talked about when we first talked about probability back in chapter 5, is that if we add up all the probabilities together, it has to equal 100% or 1. All right? So that's the same thing here underneath this premise, is that the area underneath that curve has to equal 100% or 1. Add up all the probabilities together, and they all equal 100% at the end of the day, or 1. B, the height of the graph must be greater than or equal to 0 for all possible values. This goes back to the fact that the probability of anything has to be between 0 and 1, including 0 and 1. Okay, so it has to be at least 0 and up going to 1. So that's what letter B represents, is that it has to be above 0, it has to be 0 or above all the way up to 1. So it still holds the same premise as we talked about before in chapter 5. It doesn't change anything at the end of the day. Now, specifically though, what are we going to be doing with these probability density curves? Well, the one that we want to specifically look at is something that we talked about back in chapter 3. That talks about question 3, which is, what is the normal distribution curve? Talked about the normal distribution curve here, a curve that is normal in shape, i.e. the bell-shaped curve. So this was our most ideal example that we want to get a distribution underneath. So what does that look like here once again? That kind of looks like this, right? This is what a normal distribution curve kind of looks like. Kind of looks something akin to this, right? This bell-shaped curve that we have here in this example, okay? So not the greatest bell-shaped curve I've ever made in my life, but it's a thing. All right. In any case, this is what the generic shape looks like here for a bell-shaped curve. All right, and we're going to be exploring these bell-shaped curves. In this case, though, today, we're going to be talking about specifically, we're going to be talking about probabilities underneath the normal distribution here, about what we're going to be doing here today. Okay, so let's look at number 4. All right, what are some important properties associated with the normal distribution curve? So letter A, it's a normal curve that's symmetric about its mean. So if we take a mean here, remember if we cut it in half, we talked about this before back in chapter 3. We take this, we cut it in half. We cut it in half about the mean here. We get 50% on the right and 50% on the left. Okay, so that is letter A. Let's just cut it in half. It's perfectly symmetrical, half and half, no problem. Letter B, the area underneath the curve is 1. Well, we just talked about here, it is a probability density curve of some variety, so it still has to hold the same properties as we just talked about for generic graphs. So yeah, it has to be 100% underneath the graph for everything. Seems fair. Symmetric, okay, I just wanted to restate that just for reiteration's sake. And then finally, as you see there, it follows the 68, 95, 99.7 rule, aka the empirical rule. And we talked about this way back in section 3.2. All right. This rule here talked about, if you remember, I don't know if you guys recall because it's been a while, but this is like we looked at, say, +1 standard deviation to the right, or again, +2 standard deviations, +3 standard deviations. We found out, you could go to the left here. This was like -1 standard deviation. This is like -2 standard deviations. This is like -3 standard deviations. We talked about the percentages in each one of these bars here. All right, we found out exactly how much percentage of data items in the data set are between X amount of standard deviations. Whatever. We had a picture of that. If you want to take a look at that picture there that we had in section 3.2, you can go ahead and do so. We are not using this in that same capacity here in this section. In this chapter here, we are now going to use and get data items that are not necessarily +1, +2, +3, or -1, -2, -3. Now it's going to be much more, it could be much more advanced. So for example, I could have a data item that is, 0.37 standard deviations away from the mean. And what's going to be that probability associated with that, for example, underneath a normal distribution. That's specifically what we're going to be talking about here today. Okay, so that's really the big goal here about what we're doing. All right. So having said that, let's go ahead and talk about next. Let's go ahead and talk about the next question here about how we can go ahead and do that here. We're going to set ourselves up in order to get that done. All right. So I'm going to talk about number 5 here really quick, but I am going to discuss something about number 5 here, and then I'm going to kind of skip around here a little bit on purpose. I'm going to skip around here a little bit on purpose to kind of set ourselves up for the rest of the lesson. All right, so let's look at number 5. How can we use z-score to find the area underneath the curve? How can we use z-score to find the area underneath the curve? Okay, so let's go ahead and recall what z-score is. So I put a few questions here in relation to z-score, and we'll come back to number 5 here in just a moment. But what is z-score? All right, so z-score, so as number 7 says, how do we find z-score with mean and standard deviation? Remember that z-score here is equal to the data item minus the mean divided by the standard deviation. Okay, so we took that data item, whatever that data item is, we subtracted it by the mean, whatever the mean of that particular distribution is, and we divided by its respective standard deviation, and there we go. In most of our problems here, when we dealt with z-score way back when, we were given a mean and standard deviation to work with, and we just kind of did the calculation out. No problem. Now, we did talk about, more importantly though, what are the properties of the z-scores here? Because that's really kind of the important part of what we want to focus on here in this section. What are some properties of the z-scores here? Remember that z-scores here represent how many standard deviations a data item is away from the mean. Okay. Remember that z-scores can be negative, so we can have negative z-scores. Remember that z-scores being negative, so just to point out something here on our really crude picture. Remember, if we are to the left of the mean, this represents a negative z-score. Maybe I should write it out. Remember, if off to the right here, this represents a positive z-score. Okay. So we have a negative z-score, we have a positive z-score. All right. So that's what we have here in terms of negative and positive z-scores. Now, of course, to interpret that, of course, again, z-scores can be negative. Again, each z-score is unique to its respective data item. So again, if they're the same data item, they're going to have the same z-score, but other data items will have unique z-scores. All right. So if they're different numbers at the end of the day, they'll have different z-scores associated with them. And the most important part here is that each z-score can be linked to a percentile. Okay, so talked about it very briefly last time. I think we talked about it a little bit, but not too much. But each z-score here can be linked to a percentile. Now, what that means here for what we want to do here today is we can now link a z-score here to a probability. That's what we've been talking about here since chapter 5. We can now link it to an actual probability, and we can actually figure out what kind of probability we get underneath a given scenario under their normal distribution. So that's the real goal here for today. Okay. And again, I added this to number 9. How do we find a data point associated with the z-score? You can do the data item equals the z-score times the standard deviation, and you can add the mean to that, no problem. Um, just these 3 questions here are just related to z-scores and how those work. All right, there's not a whole lot going on. We'll come back to this question here, 10. We won't come back to it today, though. We'll probably come back to it Monday. All right. Okay. Any questions so far? Any questions? Sorry, I've been kind of going on here today, but any questions so far? Oink. We are focusing on z-scores. Are we focusing on z-scores? To an extent, yes, JD. You'll see exactly where we're going to use them in this context. Okay, so we will be working on several examples using z-scores as a backbone. So we're gonna go so today we're gonna go really slow, okay, in terms of doing our examples here, because we're gonna be using the calculator here pretty extensively. So we'll talk about that. Sure. We got several things that we have to do here. So let's go ahead and do it right now, shall we? Okay. All right. So let's look at number 5. Okay, let's look at number 5 here, and we'll also look at the book here. Number 5 says, how can we use a z-score to find the area underneath the curve? Okay, so of course, that's what we're trying to focus on here. How can we find the z-score to find it underneath the curve? Now, this is essentially talking about here, hey, how do we use z-scores to find probabilities? Let's do that. So we're going to be using 2 functions on our calculator here today, all right, in order to get this done in some capacity. I'm going to move this to the right here because I'm going to need a calculator here to the left. Okay. So what we want to do here is we're going to use 2 functions here. And to get to our 2 functions, we're going to go to that same menu that we talked about here when we talked about the binomial distribution. So let's hit the second. So if you have your calculator out here, we're going to hit the second key and we're going to hit the vars key. We're going to hit the second key and we're going to hit the vars key here. Okay. And the two things that we're going to talk about here specifically in number 5, that up a bit. The 2 things here we're going to talk about here in number 5 is we're going to talk about using this first function here, which is Normalcdf. All right. So notice we have these guys. We're going to use Normalcdf, which is option 2 that you see up here. And we're also a little bit later on here, we're going to be looking at inverse norm, which is option number 3. So we're going to have option 2, Normalcdf, and option number 3, inverse norm. We'll look at both of those there. Now, one thing to point out here, really quick, before anything else happens. All right, so before anything else happens here, we will never, I put this as a note here, all right, is that the first option you see there, normal PDF, Normal PDF in this class will never be used, okay? This is something that will never, ever be used here in this course, okay? So be sure to strike that from your mind. Be sure to never use this function here for the class. We are only going to use these two in this section here, and in this class, we're going to use 2 and 3 here as our two guys. I know what you're thinking from last time. You said, hey, we use binomial PDF and CDF. I said, that's true, but that's for binomial. For normal, we're only going to use normal CDF and inverse norm. Okay, so do understand what we're doing here in this instance, okay? Be sure to write that note down if you're not sure. Okay, now, more importantly here is what exactly is the formatting here for normal CDF? Let's take a look at the formatting here. Normal CDF. Okay. All right, so as it says here, to do normal CDF, we're going to have a lower value, an upper value, a mean, and a standard deviation. So a lower value, an upper value, and a mean and standard deviation. Now, one thing that it's important here is that 0 is the default mean and 1 is the default standard deviation. So I want to point that out specifically. This is only happens if we're not given a mean and standard deviation. So if they don't give you a mean and standard deviation in the problem, you have no idea, okay, what they are because they're not given to you. Just use the default values here of 0 for your default mean and 1 for your default standard deviation. We will do problems where they will be given to us here, but we're going to be doing those on Monday. So we're going to just be focusing on the basics here today, okay? So let's focus on that. All right. Yep. So let's go ahead and do an example, all right? And let's see exactly what we're working with, right? Examples time. Let's do. Okay. All right. So we're going to do number 5 here in the book, all right, from section 7. From section, actually, I guess, oh, I missed that part. Well, I probably should do that part too. So, oh, you know what? I can do that at the end. That's fine. I'll have to flip it around. That's okay. I'll get to the meat and potatoes here with this stuff, and then we'll go. I forgot to do part of section 7.1, but it's not too hard. So we'll talk about that here at the end. It's super easy. So let's at least focus on the more important parts since I'm this deep already. Yeah, I always forget to do that. All right, anyway. We'll just do it anyway. All right. All right, so let's look at number 5 here. Determine the area underneath the normal standard curve that lies to the left of, and let's go ahead and do negative 0.43. And what exactly does this look like? What exactly are we looking at here? Let's look at see what, from a picture perspective here in this example, this is what we're looking at here. Here's a normal distribution curve. Negative 0.43 is somewhere over here as a z-score. And so all we want to do is we want to find out this whole area here, everything to the left. Dang it, I still have to say it again. Yeah, we're going to talk about that here. Yeah, we are definitely going to talk about that here. I will talk about that here in just a second, guys. 100%. I will show you how to get that E. I'm going to get to that part, I promise you guys, okay? So we're going to look at this here. So we want to find the area to the left. Area to the left of z-score here being equal to negative 0.43. Now, what's important here in this question is this is what it looks like pictorially, like saying I want to find this area that's to the left of this z-score of negative 0.43. Specifically, we want to find this to the left here. Now, if we're looking to the left here, let me move this over to this. Everything in the box. All right. We are going to be using this right here. Okay, so if we see below, or we see less, or we see something to the left, what we're going to be looking at here is we're going to use the normal CDF, this negative 1e to the 99 that you guys have asked about. We're going to get to that in just a second. The upper value, 0 and 1. In this case, we're going to use 0 and 1 here because in these examples anyway, we don't have any mean or standard deviation that's given to us, so it is what it is. Now, first and foremost here, I do want to talk about minus 1e to the 99. Minus 1e to the 99, what does that represent? Well, e to the 99 represents times 10 to the 99th power. That's minus 1 times 10 to the 99th power. Since your calculator is limited by how many numbers it can actually do and work with, minus 1e to the 99 power essentially is like minus infinity for the calculator. Okay, that's basically what it is. Okay, so minus 1e to the 99 is minus infinity essentially on the calculator. Now, to answer your question here, how do we go ahead and find out how we can plug this in? So let's take a look at how we can do that. So we're going to plug this in the calculator here. Normal CDF minus 0.43 comma 1e to the 99. I'll show you how you can get that here. Comma 0 comma 1. Okay, I'm gonna move this over again. Okay, so to get oh, I put that the wrong way. Why did I do that? I'm so sorry, everybody. I did it to the right. I'm supposed to put it to the left. Okay, my bad. My bad. My bad. My bad. My bad. Supposed to put it that way, like I put it out. All right. Which part you need me to repeat again, my friend? Yeah, I accidentally put this backwards here, so it should look like this. Up here. The e to the 99 here. So if I say like negative 1e to the 99, like let's go with this, like negative 1e to the 99 equals negative 1 times 10 to the 99th power. This is the calculator way of saying negative infinity. Okay, so 1e, like positive 1e to the 99 is essentially calculator way of saying positive infinity. Because the calculator doesn't have infinity in the calculator, all right? It doesn't. But, you know, a sufficiently large number like negative 1 to the times 10 to the 99th power will do. So, okay. To infinity and beyond. Yes, yes. Oh, yes. What am I drinking today? Yes. I am drinking a veggie juice, vegetable juice. Okay, I got vegetable juice here today. Yeah, just like that. So I got veggie juice, peach juice blend. All right, I got it from the Japanese supermarket there. It's really good, actually. Really super tasty. There it is in Japanese. There you go. Yeah, I like it. It's really good. Actually, I can't really argue with this one. It's super healthy it's healthy for you. So I can't really go wrong with juices. Let's see. Let me read this off here. Hang on. What does this have in it? All right, purified water, fine. Juice concentrates. All right, so apple and carrot juice. Um, white peach puree. Juice concentrates of white grape, lemon, acerola, sweet potato, lettuce, red bell pepper, kale, Napa cabbage, green bell pepper, broccoli, and asparagus. It has pectin, natural flavors, green beans, ascorbic acid for vitamin C, celery, pumpkin, komatsuna, ashitaba, parsley, watercress, cabbage, radish, spinach, and Japanese honewort. Yes, all in one drink. By the way, are the z-scores the upper or lower values in the equation? Okay, that is a wonderful question here. So what matters is that it's off to the left here, okay? The wording here matters here, Planet. So the z-scores here is dependent entirely on the wording of the question. In our question here, okay, there's a lot of healthy in one bottle. It's true. How much does this cost? It's like $5.99. Yeah, it was worth it though. I ain't gonna complain. Um, all right, but notice it says the area to the left here. So this reflects less than negative 0.43. Yeah, right. Veggies are good for you in a bottle. I can't argue with that. 1,800 micrograms of beta carotene per serving. Dang. Legit. Only 100 grams of sodium per serving. Wow, that's pretty good. Um, right. So this is basically talking about negative 0.43. This is negative 0.43 and below. Okay, so that's why it matters how this is written out. That's why I make the distinction here of left and right. Okay, so that's why we want to focus on the word left, and you want to make sure that you write this down in your notes here. If you see the word left, this is what you're going to be using for the word left. Something that's left, less, or below as well. Yeah. Go. Okay. So now with the real question here, because I've been trying to get to this here. How do I put the e part here in the calculator? So what I want to put in the calculator, I want to put this. So to get e in the calculator here, I'm going to put -1. Make sure you put -1, not -1, otherwise it'll give you an error. If you want the e in the calculator here, specifically the e in the calculator, all right, I'm going to put this in the chat here. So I want you to hit the second key and the comma key to get the e to show up on your calculator here, okay? So I want the second key and the comma key. And that blocky letter E is going to show up on the calculator here. So second key and the comma key, and then you could put 99 after that. Then we have negative 0.43. We have 0 and 1. And then we paste it. And so here we get 0.3336 for this problem. All right. Now, really quick here, type done in the chat if you got this answer. So please type done in the chat if you got this answer. Okay, good. Want to be sure everybody's on the same page about how they did the entries in their calculator there. So I just want to be on the safe side that everybody's got this down. If you're having trouble, please let me know now. Okay. All right. So now with that in place, there we go. We found one of them just fine. Let's try another example. Let's continue practicing forward here. All right. So let's go ahead and do the next one here. We're going to skip to number 7 here. So it says determine the area underneath the normal standard curve that lies to the right of. I'll make a number up here. So let's find area to the right here in this case. So we do an area to the right. Area to the right of z is equal to, go with 1.24. Okay, so the area to the right of the z-score here of 1.24. So in this instance, let's talk about how we're going to use this here. Let's go back to our handout. If we want to find the area to the right, in this case here we have above, more, or right. We're going to use normal CDF. We're going to use the lower value here. Positive 1e to the 99, because that will be our upper value. Remember that reflects positive infinity. 0, comma 1. Okay, so that's how we're going to enter that in here in this case. So we're going to have 1.24, comma 1e to the 99, comma 0, comma 1 here in this case. Again, the reason why 0 and 1 here is because we were not given a mean and standard deviation for this particular example. Okay, so let's enter that into the calculator there, and let's see if we get our answer. Hopefully you get the same done I do. So we're going to start off with 1.24, 1. Remember to get your blocky letter E once again, the second key, and the comma key. 99, 0, and 1. We'll hit enter. Paste that down. So we get 0.1075. Okay. All right. And so that's how we get our answer for that one. Hopefully you got the same answer I did. All right. I'm going to do another example. More examples, I know. You got a negative. Did you put the numbers in the right way, JD? Remember, 1.24 has to come first, and then positive 1e to the 99. So take a look at the screen here and how I entered it into the calculator. You should not get a negative result. So be sure you put it in the correct way there, JD. (1.24, comma, positive 1e to the 99, comma 0, comma 1. Okay, great. Yeah, order matters here, so don't forget. That's why I put lower and upper. Order matters here. You have to go you have to go the lower value and the upper value. You can't switch them around. Okay? So it has to be lower value than upper value. Lower number than higher number. Julia, got it? Good. Anybody else have any other issues? Any other questions before we move to the next example? I want to be sure everybody, again, is everybody on the same page here with the calculator stuff? Get that done. Got it? Excellent. All right. Okay. All right. Let's do the area. Let's do this here. Let's do the area between. Let's do the area between the z-score here of, let's say, negative 0.87 and the z-score here of 1.42. Okay. So can anybody tell me, how would they set this problem up? How would they set this problem up to find that area underneath the curve between these two z-scores here? I'll give you a hint here right away. We're definitely going to use Normalcdf. Okay. And by the way, there's only one Normalcdf function we'll use. So just got to plug in some numbers here. Tell me, what number should we plug into Normalcdf to get the area between both of these respective z values? Ooh. Thank you, JD. Can you guys tell me, how would I set this up here? How should I set this up here? Not sure, that's okay. Think about it. Look at the formatting here. Take a look at the formatting here. So I have another hint here. I would look at the formatting here about how you would enter it in. Okay. So just check out that formatting there. Oh, it'd be helpful if you can see the whole thing. That'd be helpful. There we go. What do you guys think? This one's pretty straightforward. If you don't try and overcomplicate it, this one as straightforward as you think it is. Well, we have a lower value, right? What's our lower value? What's that going to be? Ooh, that's close. Not quite. Now I think I understand what you guys are doing here, which is perfectly fine. Yes, that's correct, Planet. Yes, that is correct. Yes, very good. Now, let's get into a mindset here and want to talk about one of the key differences for what we're doing here today and what we did here last time. So you can actually put them together all in one package. Like if you remember here, binomial distribution, that was a very limited function. That was like less than or equal to, that was a very restricted function. Like, okay, fine. That was binomial CDF for that one. Normal CDF this time, though, you can package it all into one. You have a lower z value, you got an upper z value, you have negative 0.87, you have 1.42, great stuff on both ends, and then you could just put them together and you can find out. There you go. So the first one is for between, what do you mean by that, Planet? I'm a little confused. What do you mean the first one? The first example? Remember, the first example here was for below. That was to the left. The second example I showed off was to the right, or above. This third example is for between. The first formula, so this is the generic formula here for normal CDF. That's correct. The definition, okay. Yeah, to be fair, yes, you could qualify this as between, right? If there's no minus 1 e to the 99 or 1 e to the 99, then yes. Then yes, that is correct, Planet. So yeah, you have a lower value, you have an upper value, you have a mean, and you have a standard deviation there. Let's go ahead and take a look at what we get for our answer here. Okay, so second in vars, go to normal CDF. I'm going to plug in negative 0.87, 1.42, 0 and 1. And so here we get 0.7300. All right, that's just how it turned out. Fair enough. Okay. There we go. I hope that answered your question there, Planet. Yes? Okay, good. All right, good beans, good beans. Yes. Very good. All right. All righty. Let's do the next example. We have another example to do, but this time we're going to go backwards. Okay? We're going to go backwards, ladies and gentlemen. All right. So let's go back to the book here. All right. So let's look at this one here. We're going to look at number 13. Find the z-score such that the area underneath the standard normal curve to its left is 0.1. So find the z-score such that the area underneath the normal curve to the left is 0.1. Let's write that one down. Okay. So this time here, what we're going to be doing is we're going to be going backwards. Okay. So understand what's going to be happening here. We're going to be going backwards here. All right, so we're going to use the area underneath the curve. All right, so we're going to use the area underneath the curve to the left in this case. Remember what 0.1 represents. 0.1 represents 10%, okay? So just letting you know about that right now. Okay. Now, in order for us to actually find this particular z-score, what we are going to do is, let's go back to the handout here, is we are now going to use the other function here on the calculator that we have not done just yet, and that is number 6. How do we use the area to find a z-score? And so we're going to use this inverse norm function here. Okay, we're going to use this inverse norm function here on the calculator to find the z-score associated with the area underneath the curve. Once again, we have 0 as the default mean, and 1 is the default standard deviation if given no information regarding both. Now, I'm going to show off something here on the calculator. I want to ask you guys this question here actually really quick. You guys tell me what you see. So I want to show this off on the calculator. So on the calculator, you'll get to this submenu if you have that there. If you have the old school calculator, we'll talk about that here once I ask this question. But we have the area, we have the mean, and we have the standard deviation. Now we do have this fourth option that says tail. All right. Now with this option here that says tail, does anybody not have this option? Does anyone not have this option of tail? Okay. Want to be sure that some of you may have older calculators, in which case you're not going to see this whatsoever. You won't even see the submenu. Some of you may have older calculators. It could be recently old, and it could be like a nice calculator. This was recently put in, and I mean like a couple years back or so. This is a relatively newer option on newer software. So obviously it's on this one because it's the most up-to-date software. But if you have a calculator that's even 5 years old, still has the same submenus, but it doesn't have this option, um, then that's a possibility. Okay. So I see a couple of you actually do not have this option available to you. Now, to basically kind of set that apart, what I want to say here, you got it, yeah. So you might have a newer calculator there, JD, one that's like 2 or 3 years old that may have this option in it. Some calculators that are older, maybe not as old as my calculator, but some calculators that are older may probably do not have this option because it's one of the more newer options that they threw into this newer software package. In any case, if you do not have this option, so do not have this option, it will default to the left. Okay? So if you do not have this option of tail, this will automatically default to the left, okay? And we will need to make an adjustment accordingly. So we'll see an example. We'll take a look at a couple of examples here, okay? Where we'll take a look at a couple of examples. One where it will you just use the default, and one where it's not. All right, in this case here, what we are going to be doing is we want the curve to the left here being 0.1. So we're just going to use inverse norm. That stimulus check, right? Got to clap that stimulus check. There ain't nothing wrong with that. 1,400 bucks, baby. Woo! Let's see. It should have passed by now. So let's take a look here. Yep, it definitely passed. All right. Biden's expecting to sign it probably today. So, actually, I should say he will sign it Friday afternoon. Okay, Friday afternoon. There we go. All right. Yes, sir. I'm using my sister's calculator. That's fair. That's fair. All right. So we're going to put inverse norm here. We're going to put 0.1. we're going to put 0 and 1. Okay, so let's do that right now in the calculator. Put 0.1, 0 and 1. So Planet, this is for the COVID-19 stimulus package. All right. Okay. Jay's like, wait. All right, so what we're going to do here, we're going to put 0.1, 0, and 1 here. We'll put left. We're going to hit paste. And so as you can see here, our final answer here has a z-score of negative 1.2816. Okay, so this is the z-score associated with a 0.1 area off to the left. Yeah, welcome to that. There you go. You better demand some money from your parents. Be like, hey, I want to see some benefits. Benefits. Know how it is. You got to see some cash coming your way. I'm gonna get $1,400, so yeah. I'll take a free $1,400. Okay, that's kind of true, man. That's kind of true. That's kind of true, JD. Yeah. All right, I'm not sure. I'm not sure what it says. They take They take your birthday money. What? What do they use your birthday money on? That's rude. You need to get somewhere else where nobody's gonna take your money. Jeez. All right. I made it abundantly clear to my parents early on, like, you're not going to touch my money. So I made it very abundantly clear. But you got to assert some financial independence there. Because you know what? The only person that you can trust is yourself when it comes to the money you want to use. So I love my mom and I love my dad. I mean, don't get me wrong. It's just like the whole point as being part of a family structure is to not only help your family but to grow as an individual, and that requires being financially independent and being responsible with money. How can you ever learn to be responsible with money if you're never given an opportunity to do so? That doesn't seem to make any sense. So that's something to keep in mind. um, that's why if they're not letting you, just assert it yourself, because at some point you're going to have to. I mean, yeah, no finances since you have your own business. Good, yeah. So you showed them, right? You showed your mom. You're like, hey, I can do this. This isn't like something that's a yeah. When I got my first job at McDonald's at 15, I was like, this is my money. It goes into my account, you know, and I'm like, that's it. That's my money. That's what I'm going to do with it. It goes into my account. Nobody can touch it except for me. Okay. You take your money to the bank. You spend it's your money. You spend it on whatever you want, and then that way, you like it's in your name. You're at this point, JD, you're old enough to have a bank account, so You got your first credit card. What's your credit limit there, Planet? Oh, I have to do these examples really quick, guys. Give me a second. I gotta do this next example. You mean it didn't pay bills? Well, I was a sophomore in high school when I first started working. I had to even get like a work permit through my high school to even qualify to work at Mickey D's. So I was making, how much was I making at the time? Oh yeah, I was making good money at the time. And for good money at the time back in 1995 was this. Okay. $4.35 an hour. Ooh, baby. Baby. $4.35 an hour. I wanted to buy a TV VCR combo from Best Buy, and I got it. Darn right. There was one reason why I wanted to buy a TV VCR combo is because I put the TV VCR combo inside of my room. And so when I put it inside of my room, not only could I watch videotapes and TV in the morning before school, but then my parents couldn't send me to my room because I had something to do. So that so I planned it a little bit in advance, and I'm like, yeah, you try and send me to my room now, you can't. Mwahaha, parents. Hey, one little thing, it makes a big difference, let me tell you. Those little things, you don't see them, but they make a bigger difference than people realize. Yeah, you gotta outsmart them sometimes. It's just how it rolls. All right, but I gotta do this next one here. All right, so let me do this next one, and then I got one more thing to show you, and then we're done. All right, for the day. So we're gonna next do is find the z-score. Yeah, that's right. Find the z-score where the area under the curve is true. They do. Where the area under the curve to the right is 0.37. Okay. Where the area under the curve to the right is 0.37. Now let's talk about this one here. The area underneath the curve to the right is 0.37. So we are going to use inverse norm here. All right. We are going to use inverse norm here. Now, the important part here is what we're going to plug into inverse norm. Okay. Now, if you have the tail function here, then you don't have to do a whole lot here. If you have the tail function, this is what you would put into your calculator. The tail portion would go to the right, and then you would have something that looks akin to this. So let me show you what it is with the newer software. We're going to do it with the older software in just a second. But this is with the newer software. It'll just do the tail to the right, and it will plop out an answer for you here. That answer is 0.3319. However, one of the other things to understand is that some of you guys, your calculators are limited in function and capacity, meaning to say it automatically defaults to left and there's no option for tail on your calculator. That's fair. Since it defaults to the left, what we have to do is we have to look at the opposite side of things. Essentially, what we're looking at is this. We're saying, okay, this side here is 37% or 0.37. This is 0.37 to the right. However, in reality, if our calculator is automatically defaulted to the left, then how about if we look at the other side of things, which would be the 0.63 to the left? So how did I get that? I did 1 minus 0.37, and I got 0.63. So this would be 63% to the left is reflected the same way as 37% to the right. So 63% left is equal to 37% right. So if we're defaulting to the left like you are in the old school calculator, then what you can enter in is this. You can enter this in directly straight up and you will get your answer here. So you'll get inverse norm 0.63, comma 0, comma 1. And if we do that on our calculator here, second and bars, go to inverse norm here, 0.63, 0, 1, left. Notice we get the same exact answer here. So this is a way you can kind of circumvent and work with your default value here of left. All right. So this is what some of you will have to do because of the limitation of that on your calculator that you'll have to be aware of. Any questions about that real quick? I could talk about credit cards all day. I didn't get my first credit card. Yeah, it's just one extra step. I didn't get my first credit card till I was 30. So and be responsible with it. That's important. You don't want to shred your credit score real bad. Gotta be really careful about a credit card. Yeah, that's fine. I think that's fine. Just got to be sure you pay 10%. 10 go 10% of your credit limit should be fine. First month you always spend it to the max and then you pay back that max. You pay back 90% of that max limit and then you can spend on it whatever you want afterwards to get the maximum credit benefit. It's weird. Anyway, I have one more thing to show you here. All right. So section 7.1, by the way, we kind of skipped it, but it's really not too hard. I'll just take like a few minutes of your time, or maybe like a minute of your time, really. Okay, remember that a normal distribution looks like a bell curve, right? This is all section 7.1, basically. All right, take a look at number 19 here on the screen. Does this look pretty close to a bell curve? Would this be considered normal? Yes or no? Type yes if it looks pretty close to normal, or no, it doesn't look close to normal. So yes or no? Real quick, guys. Let's go. Yes. Yes. Okay. Good. The answer is indeed yes. They are indeed is a normal type of distribution. How about number 20? Yes, okay. How about number 20? Is number 20 a normal distribution, this graph right here? Yes or no? Moo. No. Okay. No? Okay. No. Okay, good. Correct. The answer is no. All right, good. 21. Yes or no? 21. Yes or no? No. Nope. All right. Kind of agree with you guys. 21 is definitely not. Doesn't look like a bell-shaped curve. How about 22? 22, yes or no? 22, yes or no? Looks like a bell-shaped curve, yes or no? Okay. So that's basically 7-1. 7-1 is just like, look at a shape. Does it look normal, yes or no? And then that's it. That's all you do. That's all section 7-1 really is yes or no questions about does it look like a normal distribution or not? You guys know what one looks like because it's a bell-shaped curve. So that's all you're doing for that section there. There's really not a whole lot going on there. I promise you that's it for 7-1. Most of the stuff that we talked about here is from 7-2 here today. So that's our stuff. Good beans. I'm done with that. I'm done with that section. That's it. That's all we got to do. All right. Okay. Well, in any case, ladies and gentlemen, I want to thank you all very much for coming on out here to the stream once again. Okay. Didn't we do the same for section 3 in the test? I mean, kinda. Kinda. All right. Everyone, I want to thank you all for coming out here to the stream once again. We're going to do more with section 7.2 on Monday, okay? So we're not done with section 7.2. We have more specific examples to do with section 7.2. All right, so you'll see exactly what we're going to be dealing with, like the middle 97%, or dealing with stuff that actually has a mean and standard deviation given. So we'll definitely see that on Monday. But in the meantime, is there more office hours this week? Yes, that's in 10 minutes. Or again, just contact me through Discord if you like, or email. Then I can come back on Discord or whatever and show you how to do some problems if you need to. All right. Of course, there's more office hours. All right. In the meantime, everybody, as I like to say, everybody, stay safe, stay healthy, and most importantly, everybody, stay sane. All right. Have a great weekend, everybody, if I don't see you. All right. Otherwise, contact me here right after class if you need help with your homework, or again in the afternoon. All right. Take care of yourselves, everybody, and we will see you next time. All right. Have a great one, everybody. Take care. All right. Bye. Bye, guys.